Hey everyone, it's Miss Miller. I hope that week one of online learning went well. I knew there was going to be a few hiccups, but hopefully we've kind of worked through some of the kinks and you're kind of getting used to it. For this next week, we're going to be doing equations, and I know we've covered that at the beginning of the year, but this is such an important skill for algebra next year. So I just want to make sure we get a really good grip on it. I'm going to have this video of the notes, and I'm also going to record a video on how to do it on Desmos because I want you to be able to do that as well. So here are these notes. Golden rule. This is the golden rule when solving equations. This is most important. And here it is. Whatever you do on one side of the equation, you must do to the other side. Golden rule, and y'all already know this. Whatever you do on one side of the equation, you must do to the other. If I subtract 4 from one side of the equation, I got to subtract 4 from that other side of the equation. That is the one golden rule that you've got to remember when solving. So, a solution. The definition of a solution, definition of a solution is a value that makes the equation true. So basically what that is saying is, does the left side of the equation equal the right when you plug it in? That's all it's saying. The solution is, does the left side of the equation equal the right when you plug a number in? Are these solutions? So it gives me the number that I need to plug in. X equals 4. So that means in my equation, everywhere I see an X, I'm really going to plug in 4. So instead of 3x, I've got 3, and when 3 and x are smushed together, that means multiply. I've really got 3 times 4 equals 12. Well, 3 times 4 is 12. Does 12 equals 12? Yep, here on planet Earth, 12 equals 12, all day, every day. So 4 is a solution. Yes. 4 is a solution. When I plugged in the number I got, the left side equals the right side. If we look at number next, this time it says that x equals 7. So everywhere I see an x in my equation, I'm going to plug in 7. So I've got 7 minus 3 equals 10. Well, 7 minus 3 is 4 equals 10. Does 4 equal 10? Not here. Never, ever, ever will 4 equal 10. That's impossible. These do not equal. So, no. 7 is not a solution to this equation. And remember, equation has the word equal in it. You have to have an equal sign for it to be an equation. Okay, here's our 5-step plan for solving, and I want you to go through this 5-step plan until you're comfortable with doing it. So most of you are already comfortable. If you're not, I need you to follow these steps. It'll help, and eventually you can skip a few steps when you start getting used to it. So step number 1 is always draw a line through the equal sign to designate our sides. So if I had an equation, x plus 6 equals 5, well, I would draw a line through there to designate the left side and the right side. Because remember, our golden rule was whatever I do to one side, I've got to do to the other. So draw a line. That's first step. Okay, step number 2 is to simplify. Simplify each side. And by simplify, all that means is to combine terms that have the same last name. So we can combine constants with constants and variables with variables. And remember, variables are your letters, like your x's, and constants are just your numbers. So if I had an equation, 2x plus 3x equals 5, well, I can simplify this side of the equation. I've got two things with the same last name. I've got an x here and an x here. So I can take these and add 2x plus 3x. Well, how many x's do I have now? I've got 2 plus 3. So now I would have, now I would have 5x equals 5. That's simplifying, combining things with the same last name. Next is label your sides. So one side is going to be the variable side, and we just label it whatever the variable is. So like in this case, for the ones I've been doing, I've been having x as my variable. So like instead of writing left and right up here, I would write x. This is my x side because x is already over here. My other side is the everything else side. Everything else side. And I designate that by saying E, everything else. So when I would solve this equation, only x's could go on this side of the equation, and everything that's not an x comes over here to this side. So you need to label x and e. And again, if this was a different letter, say this was t, you would just label this t instead. It's whatever your variable is. Okay, so we drew our line, we simplified, combined terms with the same last name, we labeled our variable side and our EE side, our everything else side. Now we get to start moving. Now for step 4, you can only move terms. You can only move terms by adding or subtracting. You can only move terms by adding or subtracting. So do not start dividing or multiplying yet. Right now, you're only adding or subtracting to get all of your x's on one side and everything else on the other. So like this example up here, right now I've got an x on the x side. That's okay. He can stay over. He's got an x. He can stay on the x side. But this 6 doesn't have an x. So he's got to move over to this everything else side. But the way to do that is by adding or subtracting. And you're going to do the inverse or the opposite. So since I'm adding this 6 right now, in order to get rid of it, I've got to subtract 6. But remember our golden rule, whatever I do to one side of the equation, I must do to the other side. So if I subtract 6 from this left side, well, I better do it to this side too. Well, 6 minus 6, what happened? It's gone. Now I'm left with x equals 5 minus 6 is negative 1. So now I've got all my x's on the left and everything that's not an x on the right. That's what we want to do. After you've added and subtracted, sometimes you might have to add or subtract more than one thing. So just be aware of that. Sometimes you might have to move a couple terms, but that should hopefully be eliminated if you do step 2 and simplify. You won't have to move many terms over. Okay, step number last. Once the variable is isolated, and that's a fancy word for saying it is by itself. We only have x's on one side, everything else on the other. That's all that's saying. You must multiply or divide by the coefficient. We talked about this vocabulary at the beginning of the year as well. Coefficient is just the fancy word for number in front of x. So for example, if I had 3x, 3 is the coefficient. It's the number that goes before x. I've got 3 x's. That's all that means. So like in my example up here, I don't have anything here in front of x, so I'm done. My answer is x equals -1. We finished. But in this example over here, I've got my x side, my everything else side. I've got 5x equals 5. Well, all my x's are on one side, and all of my everything else is on one side. Now, I've got to get x by itself. I only want x over here, and right now I've got 5 x's. So I have to divide by the number in front of x, and in this case, the number in front of x is 5. So I've got to divide by 5. But wait, remember the golden rule. I've got to divide by 5 on this side. Whatever I do to one side, I've got to do to the other side. Well, if I have a 5 on top of my fraction and a 5 on bottom of my fraction, those go away. I'm left with x. I only have 1x left, and look, that's what I wanted. I wanted 1x, and that's what I have, equals 5 divided by 5. Well, how many times does 5 go into 5? 1 time. So x equals 1. Those are our steps. Draw your line. Step 2 is to simplify, combine things with the same last names. Step 3, label your x side and your everything else side, your EE side. 4, start moving by adding or subtracting until you get all x's on one side and everything else on the other. And step 5, you divide or multiply by your coefficient, whatever number is in front of your x. Okay, let's try an example. Let's look at number 3. Okay, step 1, draw my line. Draw your line. And again, if you're getting really good at this and you don't need your line anymore, I'm fine with that. When you are getting questions right, you don't have to follow my steps. But if you're not getting questions right still and you're still struggling, I need you to follow my 5-step process. And eventually you'll get it and you won't have to do all 5 steps. But for now, if you do not get it, please follow my 5-step process. So we draw our line. Step 2 is to simplify. Is there anything I can simplify on this side? Can I combine 3x plus 4? No, they don't have the same last name. I can't combine an x with a guy with a no last name. That won't work. So I can't simplify on the left. Whoops. Can I simplify anything on the right? Well, there's only one number. There's nothing to simplify. So step 2, there's nothing to simplify. It's as simplified as it gets. Step 3 is to label your side. So I need an x side and an EE side. Well, since x is already on the left, it's going to be easier to keep x is on the left, everything that's not an x on the right. X is on the left, everything that's not an x on the right. So now we're on to step 4. We get to start having fun. We get to start moving terms by adding or subtracting. If I only want x's on the left, can 3x stay? Yeah, he can stay. He's got an x. He gets to stay. If he's got an x, he can stay on the x side. But this 4 doesn't have an x, so he's got to get moved over. And remember, I do the opposite or the inverse. So since I'm adding 4 on the left to get rid of him, I must subtract 4. And my golden rule is whatever I do on one side, I've got to do the other. So since I've subtracted 4 on the left, I've got to subtract 4 on the right. Well, on the left, 4 minus 4 is 0. He goes away. He's not there anymore. And I'm left with 3x. I still have the 3x hanging out. He's still there. Don't forget him. He's still on the left. And then I have 19 minus 4 is 15. Is there anything else I need to add or subtract? And how I know is if I've got all the x's on the left and everything that's not an x on the right. And I do. I've got 3x on the left, everything else on the right. And step number last is to isolate the variable. We want to just get x. Right now I've got 3 x's. So I've got to divide by my coefficient, or the number that's in front of my x. So I'm dividing by 3. Whatever I do on one side, I must do to the other side. So 3 divided by 3, if I've got one on top, one on the bottom, see you later, they're gone. And I'm left with just x, which is what I wanted. So we're good on the left, equals 15 divided by 3. Well, 3 goes into 15 5 times. So x equals 5. Now, a quick, easy way to check yourself, which one I'll show you how to do on the calculator, which you already know, and I'll show you how to do it in Desmos. But by hand checking yourself, like we did in the first 2 questions, are these solutions up at the top, you can plug this 5 into our equation everywhere you see an x. So if I've got the equation 3x plus 4 equals 19, and I've got a solution of x equals 5, well now, if I said x equals 5, everywhere I see an x, I'm going to plug in 5, and I need my left side to equal my right side. So now I've got 3 instead of x, I'm plugging in 5, plus 4 equals 19. Well, 3 times 5 is 15 plus 4, still equals 19, and 15 plus 4 is 19. So I have 19 equals 19. They're the same number. The left equals the right. It checks out, so this means that x equals 5 is a solution. Let's look at this next one. (5z minus 13 equals negative 3. Negative 3. So again, I'm going to draw my line. That's step first. Draw the line. This time my variable is a z. So I'm going to make this my z side and this my everything else side. And I know a lot of people are more comfortable with x, so if you see a variable that you don't like and you'd rather use x, change it to an x. Nobody cares. Make this your x side. It's whatever you're most comfortable with. It's just a placeholder, so you can make it be any number or any letter you would want. So only z's can be on the left. Everything that's not a z has got to go to the right. Is there anything that I can simplify on the left? No, because this has a z and this doesn't. They don't have the same last name. They can't be simplified. And negative 3 is just by himself, so he can't be simplified. So now it's on to adding or subtracting to get z's on the left, everything else on the right. Well, 5z gets to stay on the left because he's got a z in it, but negative 13 has got to go. And the inverse of a negative is adding a positive 13. And whatever I do on the left, I've got to do to the right. Well, negative 13 plus 13 is 0. It goes away. So I still have this 5z on the left equals negative 3 plus 13 is positive 10. Step 4, multiply or divide by whatever's next to your z. So I'm dividing by 5. And the reason we're dividing again is because we're doing the inverse. So since I'm multiplying 5 times z, I've got to do the inverse or the opposite. Divide by 5. If I've got a 5 on top and bottom, they go away. I'm left with just z equals 10 divided by 5, which is 2. And again, we can check ourselves. I know there's a section underneath, but there's not a whole lot of room to write, so I'm going to check it right beside it. 5z equals negative 13. Oops, not equals. Minus 13 equals negative 3. And we said that x equals 2 is a solution. So everywhere I see a z, oh, see, I did it. That is supposed to be in z. There we go. My bad. Okay, so everywhere we see a z, we're plugging in a 2. So let's go to work it out. 5 times, instead of z, I've got 2 minus 13 equals negative 3. Well, 5 times 2 is 10, minus 13 equals negative 3. 10 minus 13 is negative 3. Does negative 3 equal negative 3? Sure does. So 2 is a solution. We worked it out right. 2 is a solution. We did not make a mistake. Okay. Let's look at number 7, or number 10. I'm going to skip around a little bit. Number 10, I'm going to draw my line, label X side, everything else. And again, it doesn't matter. If I wanted to switch it, it would just be more work in this case because all my X's are already on the left. But if you like moving your X's to the right, that's fine with me. I can do step 2. I can simplify because I have X and X. They have the same last name and they're on the same side. So what's 5 plus 3? 8. And their last name is still X. Equals 28. Well, I already have X's on the left and everything else on the right. There's nothing to move. So I don't have to add or subtract. But I do need to divide by this coefficient, the number in front of the X. So I'm going to divide both sides by 8. Well, 8 on top, 8 on bottom goes away. I'm left with X equals 28 divided by 8 is 3.5. And again, you could check this. I'm not going to just so the video is not super, super long for y'all. Let's skip to number 12. And I'm posting the key for all of these, so if you wanted to work all of them out, you'll be able to do that. So this one's got kind of another step. Let's go ahead and follow our 5-step process though. It looks a little bit different than the ones we've been doing. So I'm going to draw my line, label my sides. This is going to be Z side. This is everything else that's not Z. Now for simplifying, we've got 3 times Z plus 7. This is the distributive property. This is saying that this 3 has to be multiplied by everything inside of these parentheses. So I've got to multiply 3 times Z and 3 times 7. That's part of simplifying, is the distributive property. So not only are you combining like terms, but you've got to distribute or multiply things out. 3 times Z is 3Z plus 3 times 7 is 21 equals, and I still have 21 on this side. And again, there's nothing else to simplify, but I do need to move some stuff over. I've got to move this 21 over because it doesn't have a Z as a last name. So I'm going to subtract 21. Whatever I do to one side, I've got to do to the other side. Well, 21 minus 21 goes away, and 21 minus 21 goes away. So I'm left with 3Z, and there's nothing over here, so we're just going to call it 0. When I divide by this, my coefficient of 3, well, 3 top and bottom goes away. I'm left with Z equals 0 divided by 3 is 0. And 0 is a perfectly good answer. 0 can be a solution. So don't be freaked out if you get 0. That's totally fine. 0 is a perfectly good solution. Okay, let's look at 14. So again, I'm going to draw my line, They're getting a little bit more complicated. Nothing to simplify on the left, but there is stuff to simplify on the right. Again, I have this multiplication over here. Now, the last one we did had a positive number. Whatever sign is in front of this number, it has to go with it. So if it were a positive, it would be positive 3. Since the minus sign, it's a negative 3. So I'm multiplying negative 3 times everything inside these parentheses. So I still have this 12r hanging out on this side, and I still have 33 hanging out on this side. But now I have negative 3 times 9, which is negative 27. And negative 3 times negative r. A negative times a negative is positive, so it's a positive 3r. Now there's another thing I can simplify. I'm still on step 2. I've got a 12r and a 3r. They've got the same last name. So 12 plus 3 is 15r minus 27 is still there. And I still have 33. Now I'm done simplifying. I still have to label my sides. In this case, since r is already over here on the right, I'm going to label this my variable side, my r side, and this is going to be my everything else side. Remember I said it didn't matter? And if you like doing the variable on the left each time, that's totally fine. Again, it just might take you a few more steps to get the answer. So this time I want r's over here. So 15r can stay because he's got an r, but this negative 27 has got to go. So I'm going to add 27 to both sides. Well, negative 27 plus 27 goes away, and I'm left with 15r. 33 plus 27 is 60. Step number last, divide by my coefficient of 15. Whatever I do to one side, I've got to do to the other. 15 on top and bottom goes away. I'm left with r equals 60 divided by 15, which is 4. R equals 4. I think that's all the ones I'm going to work. I will do this word problem down here because I think it's important. We need to work on word problems. Your school's drama club charges $4 per person for admission to a play. The club borrowed $400 to pay for costumes and props. After paying back the loan, the club has a profit of $100. Now, you know me. You've got to mark up your problem. You have to mark up your problem. So we circle all of the numbers. Any numbers, we're in math, so we care about the numbers. Those are important. And then we mark up our math talk words. So per means to multiply. Borrowed. Well, what does borrowed mean? Am I getting that money? No, I have to owe that money back. So I have to subtract that money from whatever I make. And then the club has a profit of $100, so I know that this is $100. That's positive $100. So when I go now to write my equation, the drama club charges 4 per person, 4 times however many people, 4x, given to me right here. So I make 4 times however many people come, but then I borrowed 400. So whatever I make, 4 times however many people, I've got to subtract that 400 because that's not my money, I borrowed it. And it says after paying back everything, we have $100. So all of this should equal 100. So I can figure out how many people came. And B says how many people attended the play. So that's just me solving my equation. 4x minus 400 equals 100. So I draw my line. Nothing to simplify. This is my x side. This is my EE side. Add 400 to both sides. Left with 4x equals 500. 4 divided by 4. X equals 125. So 125 people came to the play. And I guess I'll go ahead and do this last example if you're still listening. You have 96 feet of fencing to enclose a rectangular pen for your dog. To provide sufficient running space for your dog to exercise, the pen should be 3 times as long as the width. You know Miss Miller. She has to have a picture. I'm a visual person. I can't do all these words. So I'm going to draw. I know I'm drawing a rectangle. There's my pen. And it told me that it has to be 3 times as long as it is wide. So wide, we don't know how long it is wide, but we're going to call that W. But then the length is 3 times whatever W is. And it tells us that 96 feet is used. So I have to use 96 feet to go all the way around the rim. So the perimeter equals 96 feet. Well, what's the formula for perimeter of a rectangle? It's on your formula chart. P equals 2 times the length plus 2 times the width. Well, I know what P is. It told me 96 equals 2 times, what's our length? Well, this is our length, 3W. So 2 times, instead of putting L, I'm putting what we have for L. And we have 3W for L. So 2 times 3W. Plus 2 times, we don't know what W is, so W is just staying W. Well, now I start solving. I'll solve my equation that I have. So I draw my line. I can't simplify the left, but I can simplify the right. I can multiply this 2 times this 3. So instead of having 3 W's, I now have 6W plus 2W, and it still equals 96. And I can keep going because I've got 2 things with the same last name. 6 plus 2 equals 8, and his last name is W, and I still have 96. Do I have anything to add or subtract? No, because W's are on this side. Everything else is on this side. We have everything on the correct sides. So now I'm just dividing by the coefficient of 8 on both sides, and 96 divided by 8 is 12. So W equals 12. The width equals 12. Now that's not what our question was asking. Remember, our question asked, find the dimensions of the pen. Well, I got W. W equals 12 feet. There's 1, but I still need to find the length. How would I do that? Well, I know the formula, length equals 3W, and I know W, so couldn't I just plug in what I know for W into here? Yeah, let's do it. So length is really 3 times 12. 3 times 12 is 36. So width of 12 and a length of 36. Okay, there's your refresher on solving equations. Again, I'm going to post a video on how to do it on Desmos. I recommend you watch it because it's a whole lot easier than solving it by hand. But solving equations is a really important skill that never ever goes away. You need it all throughout all of your college classes, all of your high school classes. So please practice solving equations. Thanks, y'all. Bye.